Oh, hello everybody. I do apologise for the bit of a delay on this video, but lesson 5, here we go. And this is one that I've been looking forward to for a very, very long time. Oh yes, because this is one where you get to impress everybody and make them... You can trick them into thinking that you are the brainiest mathematician in the world. Let me just show you. Here's an example. You'll be able to show them numbers like this, woo, big numbers, and you'll be able to say whether they are in the 2 times table, 3 times table, 4 times table, 5 times table, and you can sound really intelligent and brainy. So for instance, look at this one, 253,155. I know, without using a calculator, and in just an instant, in 2 seconds, I can tell you, and you will be able to do this as well, that that is in the 3 times table and in the 5 times table. Oh yes. Ooh, let's do it. To do that, we need to learn about multiples, okay? Now, I love multiples, they are awesome, because basically all you have to do is get any whole number that is positive. They're called natural numbers, by the way. So any whole positive numbers, so that's your 1, 2, 3, 4, 5, 6, 7, 1 billion, 255,620. You get the idea. It does not include 0, by the way, and no negative numbers or decimals. So they're called natural numbers. If you multiply any natural number by another natural number, you will get a multiple. All right? Really, really easy. I'll show you how. For instance, multiples of 3 are 3, 6, 9, 12, 15, etc. Okay, so you just go through your 3 times table because I'm multiplying 3 by any other natural number. 1, 2, 3, 4, 5. I've also multiplied by 10 to get 30, by 100 to get 300. I've even times it by 2,576 to get 7,728. So I know that this number here is a multiple of 3. Here's another example. I've got multiples of 9 here. So I've got 9, 18, 27, 36, 45, 54. I've times by 11 to get 99. I've times by 1001 to get 9009. I like that number. It's got nice symmetry. And check this one out. I'll just put it into a calculator. Have fun with it. Why don't you do it? I put in 9 times 3,333 and I got 29,997. Awesome. Yeah. Check out this example. You can even find multiples of a number by multiplying them in different stages. Check this out. So I've got 3 times by 2 gives me 6. So that's a multiple of 3. If I multiply that again by a different number, a natural number, by 3, so 6 times 3 is 18. And then 18, I know, is a multiple of 3. Check it out. Because it's the same as doing 3 times 6 gives us 18. But I just did it in 2 different steps. 3 times 2 gives me 6. 6 times 3 gives me 18. And 3 times 2 is the same as times it by 6. I just thought that was quite cool. This is called the transitive property. Have a go at doing it. And check this out on a calculator. I'm just going to show you a cool little trick that you can do to find all the multiples of any number. I'm just going to show you with 5 first. So what you do is you do 5 plus, and then 5 plus 5. Or on some calculators, all you have to do is 5 plus, and then you just do equals, and then you just keep pressing equals, and it gives you all the multiples of 5. Check it out. 35, 40, 45, 50, 55, 60, and you just keep tapping equals, and it gives you all the multiples to infinity and beyond. Okay, here's where the magic will happen now, boys and girls. So here we go. I've got 23,012. We will now be able to find out if they are a multiple of 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. So here we go. We're going to do number 1 first. So 1. Every natural number, so there's a whole number that is positive, is a multiple of 1, e.g. 1, 2, 3, 4. So is this a whole number? Yes, it is. So that is a multiple of 1. That's the first one done. 2's. All even numbers ending... so that's numbers ending in 0, 2, 4, 6, or 8 are multiples of 2. Perfect. So is that a multiple of 2? Yes, it is, because it ends in a 2. It's an even number. So that's also a multiple of 2. Now, number 3 is a little bit more tricky. Any number that has a digital root of 3, 6, or 9 is a multiple of 3. So let me just show you how to work that out. Okay, to find the digital root of 23,012, I'm simply going to add all the digits up. So here we go. 2 and 3. Add together. Add the 0. Add the 1. Add the 2. What does that give us? 2 add 3 is 5. Add 0, still 5. 6, 7, 8. So it has a digital root of 8. So going back to our 3 times table, is it the 3 times table? It can't be, because it doesn't end. The digital root is not a 3, 6 or 9. So it's not a multiple of 3. Let me just give you one more example of calculating a digital root when it goes above 1 digit, when it's 2 digits. So let's just put in 9,234, for instance, okay? So I'm going to add them all up to get its digital root. That's 9 plus 2, that's 11, plus 3 is 14, plus 4 is 18. Okay, when you have a digital root of a 2-digit number or a 3-digit number, you then have to add those digits up again. So then it'll be 1 plus 8. So it has a digital root of 9. Now, is that in the 3 times table? Yes, it is, because it ends in a 9. That is its digital root. So 9,234 is in the 3 times table. Okay? Oops. Okay, number 4, the green one. If the last 2 digits of a number give a multiple of 4, then that number is a multiple of 4. So let's have a look at our number again. Last 2 digits is 12. We should know that, yes, that is in the 4 times table, isn't it? 4, 8, 12. Perfect. So this number is in the 4 times table without even having to go through, use a calculator. Perfect. Number 5, any number ending in 0 or 5 is a multiple of 5. So let's have a look at ours. Oh, no, it's not. So 5s don't go into that number. Never mind. Okay, to see if it's in the 6 times table, a multiple of 6. It's very similar to number 3, okay? So it's got to have a digital root of 3, 6 or 9, but it must be an even number for it to be a multiple of 6. So let's have a look. So let's just go back. So we had already worked out that the digital root was 8, I'm afraid. So no, it won't be in the 6 times table. Never mind. Oh yes, here, look, we've got 7s and 8s. Now I'm not sure how to work out the multiples of 7 and 8. So I'll love it if one of you guys could find out what those could be. Anyway, number 9, any number that has a digital root of 9 is a multiple of 9. Well, we know it has a digital root of 8, so no, that is not in the 9 times table. And any number ending in 0 is a multiple of 10. And again, it's not a multiple of 10. So, to conclude, so 23,012 is a multiple of 1, 2, 4, and 8. But we're not going to stop there, boys and girls. No, no, no. We are going to blow your parents, your friends and family out of this world. Check this out. I've found massive numbers, the populations of different countries to be precise. So I found the UK population here. We've got 65,246,001. Wow, that is a lot of people. Then in the USA, we've got 325,245,056. Wow. And then we've got India, 1,266,883,584. And then the world's greatest population of a country is China, and 1,366,993,920. Wow. So the task I want to pose to all of you boys and girls, and parents indeed, if you want to have a go, is to find out massive numbers like this. They could be telephone numbers, could be the populations of different countries like I've done here, and find out which numbers go into these, which are any of these multiples of 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Some of you might already be able to guess just by looking already. Wow, so many cool little tricks. God, I love maths. It's so cool. So yeah, learn all those different tricks and impress your friends and family, and I can't wait to see all of them. Bye for now.